Now this lecture is regarding regression analysis using simulink. Now over here we have a simple problem of regression analysis, a linear one, and we'll try to implement using a simulink on that. Now let's suppose the equation is y equal to beta 1 x1 plus beta 2 x2 plus so on. Now all x1, x2, x3s are the independent variables and y is the dependent variable, and beta 1, beta 2, beta 3 so on are the regression coefficients which we need to identify. Now epsilon represents the error which will be generated from the one we have the x values, that is basically this thing, the error generated. We'll calculate that. Now for different values of x1, x2, x3 we have y1, similarly for x2's y2 and so on. Now this entire equation can be written in the terms of a matrix where capital Y is nothing but the values of y1, y2, y3, y4. Capital X matrix represents all those variables of x1, x1, 2, x1, 3 and so on. Beta represents the coefficients which are the unknowns, and error will be the error generated, epsilon 1, epsilon. So this entire equation can be redefined as y is equal to capital X beta plus epsilon. We will try to take a simple example, see how to solve this thing analytically and then implement it on the simulink model. Now the example over here is, suppose we have a simple x with us which is this matrix, y is this matrix. Now this is actually x, y and z. It's a, in this there are only 3 betas and obviously we'll have 4 errors, different errors. So it's basically 4 by 3 matrix. Now analytically what we used to solve is we first calculate the x transpose, that is this thing, then x transpose gets multiplied by the x, this thing, and then we take the inverse of this, that is this. Now x transpose into y is one term, then when the x transpose x inverse and x transpose x y gets multiplied, we get the variables of b. Basically the Kramer rule is being applied over here. So these are the values of beta 1, beta 2 and beta 3. So using these beta 1, beta 2, beta 3 and the values of x, we'll get the values of y. Now this is y calculated, this is y which we have the data with us. So the deviation will give me the error. Now we'll try to solve this thing using simulink. Now in simulink, how to solve this thing is, first we'll open our simulink model. So we have a simulink model. We'll create a new file, a model file. Over here we'll create a constant over here. Now this constant, in this constant we'll try to put all those values of x. So for that we'll write 5 space 1 space 2 done, 4 minus 2 and 1 done, then we have minus 1 3 and minus 1 done, and 0 2 so done. Now this is 4 by 3 matrix. We can resize this and we have this. Then we'll have another matrix with us which is your y matrix. So y matrix is was 7 minus 2 8 and 0. So it basically shows you in this way, but we want in the row wise. So for that we'll double click this and untick this interval, so it will be converted into a row. Now first thing is we want to calculate the transpose of this. For this, in this library we'll search matrix square. Otherwise it's placed in a single signal processing matrix square, which is there in the signal processing over here. We got it. So we'll try it over here. Okay, we need a transpose matrix also. So we have a transpose matrix also, and we need a matrix multiplication. have matrix multiply. So we have a matrix multiply 1 and we require another one. Then we require a display that will display both our errors and the beta values. So we have this. And then finally we require a summing point. So let's rearrange this thing, entire sheet. Okay, now this matrix will calculate, we'll go into this can be resized. Now there will be 3 inputs in this, so there are 3 inputs. First input is this, done. Then the second input will be the transpose of this. This goes into the other one will be the value of y, which will be fed into this. So this is actually x inverse into x, that is x transpose of x into transpose of this. This goes into the display, and the part of this will go into the matrix multiplication to calculate your y. We'll assign all those values later on. Further, then okay, we have one variable over here. We'll again try to reconnect this thing. Then again your 1y will go over here. Then this thing will go into over here, and this will be over here. So this will go over here. Now what are all these connections were? This was your capital X, this was a capital Y. Okay, done. So what was this value? This was your X transpose X. Okay, this was your X transpose. So whatever you calculate over here in the general, okay, we are getting one connection. We forgot to get the one connection, that is the inverse, LU inverse. We want the inverse of that also. Okay, so we'll place that LU inverse over here. So we'll remove this connection. This connection will goes into this, and we'll get the output. Now from the output of this, we basically have x, the inverse of this. From here. Now what is this? This was y. This will calculate. Now this, what does this matrix output gives? This matrix output actually gives me the value of beta, which was nothing but xdx inverse star log x transpose y. Now x transpose goes over here, y goes over here, this goes over here, all gets multiplied, and it will give me beta. Now this beta goes back over here, it gets multiplied by x, it will give me x beta. Now this x beta gets compared up. So in order to compare, we'll use a minus sign over here, a minus sign. Now the entire thing is run. So let's run it, and this run. Now we can change the display settings, and we can change the, so this is your, you can say your beta, and this represents your error. You can clearly see with the values over here. So beta values were 0.23, 2.9917. So now model it was the same, and the errors are -63, 1.1 and 1.2. So this is how you can solve regression analysis using simulink model. Now the only thing is you can change your XX model, you can change your Y model, and simply run. Everything remains the same because all these values are basically the simple terminologies which will calculate the transpose, the inverse, and the multiplication. Thank you.